Welcome back to Ox Tools. I'm Tom. So we're finally getting to the chip control, boys. This is chip control, the Major Tom. So what we're going to do is we're going to grind a tool bit, and we're going to do some test cuts in this steel bar that Adam sent me. And I just wanted to kind of put out there too that this is open to anybody that wants to participate that may have something to add to the conversation. So we're kind of hoping that one of the keys or all the keys and some other folks kind of dive in and get involved and show us some of their tricks, because I think there's something to learn from everyone here. What I'm going to do, so Adam showed one of his favorite grinds, which is was a nice tool bit, and it performed very well. So what I'm going to do is slightly different. I'm going to do an old school grind with a lead angle and a back rake. So what that means is in the direction of travel, we're going to have a lead angle, and this has the effect of thinning the chip slightly, and the back rake makes for more of a shearing effect. So it's kind of an old school, what I would call South Bend lathe, how to run a lathe book type grind. Anyway, so it'd be slightly different than what Adam did. You guys will get to see that grinding process. I got some tool bits that I dug out that are various states of condition, and then we'll talk a little bit about the cutting speed. I got a little chart that I'll be looking at. Let's see, what else? I don't know. I've already done some test cuts, just playing around, and you guys saw the chip I had in here the other day, so it's kind of a teaser. So anyway, let's get an apron on, and let's go grind some tools, and let's go turn some steel. Okay, so I just wanted to show this little thing here. This is this, and you can see it's pretty well worn here. This is this Morse Machinist Practical Guide. Anyway, this is, actually I use this a lot still. It's got some good stuff in it. But what I wanted to show you in the back here is they have just some surface feed conversions, okay? So you can convert cutting speeds, desired cutting speeds, into RPM, okay? So the thing we're working on over there is, it's about 2.5 inches in diameter here. And we're going to be running roughly 100 surface feet per minute. So if we look here, we're at 153 RPM, something like that. So we can go between 100 and 110. So what I say, 150 to 160, 170, something like that. And then this goes all the way up to 12 inches. So and down to, you know, a gnat's, you know what. The same thing can be done this way. If you take your cutting speed and you multiply that by 4 and you divide by the diameter, okay? So in this case it'd be 100 times 4 divided by 2.5, okay? And it yields a result very close to what this chart says, okay? So if you remember that little formula and you remember some cutting speeds for different materials, then you can kind of sort it out on your own fairly quickly. Anyway, I like this book, and not just for this. The main thing that I like it for is it's got some good drill feed rates. Okay, so when you're programming CNC machines, it's got a bunch of different materials, and it's got some speeds and feeds for drill bits of different diameters. So this is something you have no sense of feel with CNC equipment, so you have to program it correctly, right? And different materials require different feed rates. Anyway, that's kind of a separate discussion, but that's one of the nice little charts that's in this book here. And obviously you can probably find all this junk online too, but this goes in my toolbox. I don't have to have a clean finger to work my phone or, you know, or internet connection or whatever. It works no matter what. It works when the lights are out, okay? And I think Adam's shown these, and I may have shown this before too. The other one I use in here, just to point it out, oops, let's see if I can find it. It's the one with all the yellow on it. Of course, so I won't be able to find it. Only flip through it a million. All right, come on, you. There it is. So this is end mill. So end mill speed, high speed end mills, and for different materials, and RPMs and chip load per tooth, which is important once again when you're programming feed rates. Not so important on the Bridgeport because you just have basically a knob and you're just kind of eyeballing it. But when you're programming a feed rate, it's important to know what a reasonable chip load is, and you convert that into inches per minute. Okay. Anyway, so that's that. We're going to look at some tool bits next, and then we're going to do some grinding. Okay, so we get a little assortment of some high-speed tool blanks here. There's a couple different flavors here. I think Adam used a Rex 95, and that's a Rex 95. And I didn't really have any unground Rex 95 blanks. We're going to probably use the same type that he's using just to eliminate that. Now here's a pretty funky looking one there. That may just get reground there. So that's another Rex 95. This is this plain Jane high speed here. This one got a factory end on it still, so we might use that one. Half-inch F&D GR.B. I think this is this plain high-speed steel too. And then we got a Latrobe Dynavan. So that may be a different alloy, although it looks just like high-speed to me. The cobalt alloy bits are slightly more gold color than just plain high-speed. So we'll set those aside. So we'll kind of stick with this one or one of these, and there's a bit of regrinding on that. This one could probably work. What I'll probably do is go over there and just knock that off, kind of off camera, get rid of that thing on the end, and tune it up a little bit, and then, or you know what? Maybe I'll just mark this one. Let's just do that. I think we're just going to go with that. So, like I said before, we're going to do kind of an old school lead angle grind. Okay, so we're going to have about a 10 degree, something like that, lead, and then this will be roughly 90 degrees here. Okay, and then we will, this will slope down and back in this direction here. Okay, and then obviously we have to have some, see, end, side, top. Okay, end, side, top. All right, let's put an E on that. All right, so we're going to put, roughly 10 degrees, 10 degrees. We're just going to do 10, 10, 10 probably, approximately, to start with. No chip breaker yet, and then we're gonna test that tool out and kind of see how it goes. Okay, so I got my water bucket. I'm kind of ready to go here. First off, I'm gonna kind of just dress the wheel a bit. Open it up and get it more free cutting. I already ground a little bit just to, see how it looked on camera. So I'm just putting the end relief in now. I'll kind of start with that. Okay, looks pretty good. Now I can start working on the side. I can feel the wheel has slowed down a little bit on its cutting, which is, you know, no big deal. We just open it up again, give it a little scudge there. So we're going to need a pretty good edge on the side there, or the length, I should say. All right, that's looking pretty good. Give us close. Alright, I'm going to stop for a sec. Alright, I'm going to cool it off real good now because I'm ready to start the top rake and back. Let's just give it a kiss. Check to see if I got it started right. Okay, let's see, that's looking pretty good. It gets hot quick because your finger's right opposite the where you're grinding there. Let's see if you guys can see that. Okay, so we want that to extend all the way up to the tip. Looking pretty good. Might be a little steep on the angle, but let's.
spot right there that needs to get it. Touch this up. Okay, I like the look of that. That looks pretty tasty. I don't think I have quite enough underneath here. I didn't have enough underneath the front here, or the side I should say. Alright, that's got it. Alright, I'm going to hit it on the fine wheel, and then we're going to put a little flat there, and then lap that into a little radius, polish this thing up, and then we're going to give it a test drive. Yeah. Okay. Okay, same thing here. Going to deglaze. I'm holding it up that way that I can match the angle that I've already put in it. I don't really want to change the angle, I just want to get a finer grind on it. Just like that. All we're doing is just getting a slightly finer grind on it. Okay, alright, that's looking pretty good. Alright, I'm going to put a little flat here. Okay, hopefully you can see that small one. Alright, now we're going to go do some lapping. Okay, so we got our honing stone here. Nice and clean, and you know, some guys have asked me why I don't use a hand one. I like to feel the flat myself, and just keep it flat. Okay, you can see it's starting to work that edge there. Okay, so we got a nice polish right on that, right on the edge. Okay, that's looking pretty good. See this end here. So I'm feeling the flat. And I like to go in the direction that that it's going to see the material. That's just my preference. Basically, you're just looking for a smooth, uniform edge. You see the polish on the little land there? Hopefully you can see that. Let's see. Let me take a look at the little viewfinder there, yeah. Okay. We got that. Alright, then we're going to do this one here. And you can see the stone's loading up a little bit there, but I'm not too worried about it right now. Oh yeah. Oh yeah. Mr. Wizard likes it. Okay, so now we're going to address our little flat here, and it can be a flat, you know, or it can be a radius. I just kind of prefer a radius myself, but it doesn't make a lot of difference. I just feel like I can control it better when I come around the corner like that. Well, that's a fine tool. I think that's ready for a little testing, boys. Let's go over to the lathe and see what we can do with that. Okay, so we got a tool block here. Here's our tool. I'm going to put a shim underneath it, and this is copper. It's about 6 millimeters thick, about 1/4 inch. Now we're trying to do some heavy cutting here, so I don't want to stick it out like this. I want to keep it sucked in nice and tight. Get that set like so. Basically flush there. Secure these. And you see I'm going back and forth there. I want these both kind of evenly bearing there. Okay, that feels pretty good. Oops. We're going to start out. We're going to start out on center. So we're going to use our new handy dandy. And here's what's neat, right? I just hang that over like so, and I just run this up until it touches or gets close. I just double check it. Now with the Aloruses, typically you have to, kind of lock them a little bit to get a good feel where where it's going to lock up. Okay, so that's that. So we're going to start out on the center, and then we'll try some different center heights and see how that affects the cut. Okay, and you saw how quick that was. I didn't have to hold anything, and this is locked, for a long time, right? If I don't bump it or drop it or unscrew it. Okay, so I'm going to turn the camera around, and we're going to look at our turning victim here, and yeah, boy, I'm liking the look at that tool. Okay. Okay, so we've already been playing around with this, and you guys know that, so that's no big secret here. So what we're going to do is we're going to work on this smaller section to start with. We'll do a couple of warm-up cuts and see what we get. So we're we're around 1.5 inches here, okay, and so we need to get our spindle speed correct here for that diameter, right? So we're going to start out maybe, I don't know, 100 feet per minute cutting speed. So that's roughly, I don't know, 240 or 250 RPM, something like that is what we're looking for. The closest speed that I have is 285, so we're gonna go there. Let's see, did I get that right? Is that it? That looks like 285 to me. Okay, so let's do a little test cut here. Just gonna touch off our nice brand new tool here. Okay, there it's just kissing. I zeroed the DRO, and let's try Let's try 100 thousandths on the diameter. So this is a 100 thousandths diameter reduction. And oh yeah, let me, I almost forgot. I want to check the feed rate here and see where the heck we are. So 3 low. 3 low. So this should be about 5 thousandths of an inch per rev, or 0.13 millimeter per revolution. 100 thousandths depth of cut. Let's see how she does. Okay, looks pretty good to me. Looks pretty tame, actually. Alright, there's no problems there. Your typical mild steel finish. We could probably hone that radius a little bit more. Maybe we'll do that when we take a little break here. So I'm going to dial in another 100 thousandths. So that puts us at 200 thousandths diameter reduction. So that's just 100 now. It'll catch up to that other cut in a sec. Okay, here comes 200. There's the 200. Alright, no problem. Looking pretty good. Alright. Yeah. Here's my pliers. There they are. Get that out of there. Alright, so I'm going to try a little higher feed rate. So this is I believe this is 10 thousandths per rev. Let's go back to our spot here. I'm just going to drive in there. This is 10 thousandths per rev, or 1/4 millimeter per revolution. Alright, not bad. Okay. And these are not super nice chips. Let's keep going here. Back to 5. I'm going to go for 300 depth of cut. Now that's just 100. It'll be 300 when we get up to that shoulder there. See how it behaves. As our diameter gets smaller, theoretically we should be increasing our spindle speed too. But for this it's okay. Alright, there's 300. Alright, not bad. Piece of cake, right? Alright, so where are we now here? That's kind of the first chip. Okay, so technically we would be increasing our, so we're 1 1/4 now, so, oh, that would probably, what is that? Look at my little chart here. It'd be like around 300 now, so, well, actually we're pretty good still. So, all right. I think I'm going to take this tool out and I'm going to hone that radius a little bit more, and then we'll come back and do another cut. Okay, so let's set it in the frame. Yeah, okay. So what I did is I went back and I honed the top again, and I honed the radius a little bit larger. Okay, and we'll see if we can improve this finish a little bit. And I'm just going to come up and touch off here. That, and let's take 100 and see if our finish is better. Alright, yeah, I like the finish better. Okay, so when we come up to that shoulder, that'll be, I believe, 400 thousandths on the diameter. So let's see what she does when she bumps into that. Alright, not bad. So this tool isn't ground back, oops. This tool isn't ground back far enough to take that whole thing in one whack. So we've reduced this down a little bit now. So we can come back at this shoulder now. Actually, why am I trying to talk over the machine? So you can see the finish is improved by the nose radius change, okay? So just for fun, let's we're going to do a little bit more on this one, but what I'm going to do is I'm going to raise it above center a little bit, which has the effect of increasing the top rake. So let's try that. Just come in another 100, see what that does. Hopefully we got enough clearance underneath there. Let's see what it does. Pretty tasty. And this is still 5,000 feed rate. Let's take a quick look at that. Yeah, okay, finish looks okay. Alright, I'm going to increase the feed rate a little bit. This will be 10 thousandths per rev. Come up to that shoulder. Once again, this is only 100 thousandths on the diameter. Alright, that looks pretty good. Get it out of there. So you can see I actually raised that a fair amount. Let me get some kind of measurement for you there, how much above center I am now. And then perhaps maybe we can see it here. Okay, so yeah, you guys can probably see that. No, you can't. How about if I get in the frame? All right, so let me just back up here. That'll probably be better. And I can get into the frame better. Okay, so there you can kind of see, you can kind of, you know, you're at a kind of a bad angle. So I'm about 1 millimeter above center on this one right now. So normally we run on center typically, but you can, oops, wrong way, Mr. Wizard. You can change the center height to get different effects also. So, all right, so I'm back on center. Well, what do you say we do some big cuts, huh? Let me check the camera and we'll go. Okay, so I've changed the spindle speed, and we're down at 160 RPM now because we're working on this bigger diameter. So, and we're going to start out at 5/1000ths of an inch feed rate. I'm going to touch off. Okay. Zero my DRO. So we've already been to 300. Let's go 400 on the, let's go 1/2 inch. We're just going to go 1/2 inch on the diameter. See how that is. Let's see how that behaves. Okay, here we go. Alright, it's peeling a nice chip. Now, you'll notice that they're kind of long. Ideally, we would want something like that, kind of small, and we'll get to that. Okay, we'll get to that. All right, so that was 1/2 inch. Let's go up to 600. Yeah, we'll go 600. Come on. That's 600. That'll be 600 when it hits the other shoulder there. It shouldn't take too long. Okay, here it comes. There we go. Alright, that's peeling a nice chip. No problem with the machine taking it. Tool's cutting nice and free. Okay, the chips are not short though. Alright, that was 600. Alright, we're going 750 now. $750 total when I get to this shoulder here. That's diameter reduction, just as a reminder. Okay, here it comes. Alright. It's taking it, no problem there. Keeping the lube on it. Alright, well. That was 750. That was a piece of cake. All right. You can see the width of the chip there, the indicator. I don't know. Should we go for more? What do you think, guys? I think so. I'm gonna go 875. I think. All right. That's 875. And I think I'm going to have to regrind the tool to go more than that. We got to leave some room for Adam to play with this too here. Or Keith or whoever wants to play. So okay, so we're going to hit 875 pretty soon. I'm going to stop it here for just a second, right when we get up there. Actually, that's probably close enough. And what I want to point out is you can see here, I need to grind more tool. I'm right there. I can only go, well, I don't know. This looks like about it here. So I'm going to have to touch the tool up to go more. All right, 7/8 coming up. Here we go. Cuts like butter. Alright, and there's some chips. Alright, so let's stick the old ruler in there. You guys can kind of get a sense of that. So it's 7/16 on the radius, okay? That was 7/8 on the diameter, 7/8 diameter reduction there. Tool's looking pretty good. It's got a little built-up edge on it, but in general, it's oh, no, it's coming right off. So okay, So I had a little built-up edge, but I was able to pop it off with my scale. So it wasn't welded to the tip, all right? The tool's warm but not hot. The part's warm but not hot. And there's some of the chips there. Okay, and there's our width right there. See, that's about 7/16 wide. Oh yeah, you know what? We should try the higher feed rate and see if we can get 10,000ths of an inch per revolution out of this thing. All right. Okay, so we're set for 10,000ths of an inch per rev feed. Let's give it a go. Let's see what happens. Here we go. Alright, it's doing it. And the chips are breaking. The chips are breaking a little bit better. And you can see we're getting a little color in the chips now too. Okay? So that means you're working there, okay? You're getting some color in the chips. Alright, I shouldn't be talking with this thing. So there's some of the chips. Actually, I'm going to zoom out a little bit and we'll look at some of the chips here. Okay, so here's some of our chips here at that 7/8 depth of cut, or yeah, 7/8 depth of cut. So this pile here represents 5,000ths of an inch per revolution feed rate, and this is 10,000ths of an inch per revolution feed rate. Okay, and you can see the distinct difference in the chips here. These are actually these are pretty good chips here. They're short and they're breaking, and they're getting a little color to them. And this golden tan really is kind of where you're, you know, you're working it and you're using your tools. This is, you know, kind of longer, thinner chips, and they don't want to break. These are, you know, obviously these are thicker, and so they break apart. So that's just a change in feed rate. We didn't change any RPM. We didn't change the tool. We didn't change the depth of cut. So all these bits of the puzzle here, the tool, the speed, the the feed rate and the depth of cut all play a part in the chip formation. Okay, so what works at a lower speed and a lighter depth of cut doesn't necessarily work at the opposite of that. Okay, anyway, that's kind of important to note that you know, if you change any of the legs of the tripod, so to speak, then the chip formation changes also. Okay, so let's see, what else do we want to say there? Tool's looking pretty good. Anyway, so Adam, there you go, buddy. That's 7/8 depth of cut, and not bad looking chips there. And what else can we do? I don't know. Over to you, Adam. So the last thing I wanted to show was I wanted to show this tool here, and this is after all this cutting here, and it's fine. Okay, it's ready for more, and we may have to grind it back a little bit farther. You know, grind back into this area. It's not writing on there, of course. It's wet. Grind this back a little farther so we can get onto this a little deeper here. So anyway, thanks for watching.